Okay, good morning class. So at this point we are looking at let's get here first, trigonometric graphs. We're looking at the examples for exercise 6.7. We're looking at more complex graphs, not so? Exercise 6.7, and that was on page, the exercise on page 208. 208. Okay, and this more complex graphs, this example is on page 206. Okay. I have done this with you already, but at that time it was load shedding. Okay. So I'm just going to go through it so that we can have this recorded as well. So here we are told that in general, if the equation of the graph is of the form y is equal to a sine b open brackets x plus p plus q, then we start to know that we will be drawing an adaptation of the y is equal to sine x graph. A will affect the amplitude, b will affect the period of the sine x graph, p moves the graph of sine x horizontally, and q moves the graph of y is equal to sine x vertically. So that basically moves the graph up and down. P moves the graph left to right, but it's the additive inverse thereof. And B is the period of the graph, and that tells you from neutral to your maximum how high that is. Okay. So let's look at this example. Obviously the example is on page 206. So they ask you to sketch. Okay, now this also affects, if you have y is equal to a cos b open brackets x plus p close brackets plus q, it affects your cos graph in the same manner as it's affecting the sine graph. However, the mother graph is the cos graph. Not so. Likewise on the tan graph, same story. Okay. Now it's just using sine here. Alright. So firstly they ask you to sketch the graph of y is equal to sine 2x plus 60, where x is an element of negative 210 degrees to 150. Okay. So what I'm going to do is I'm going to just get a grid. So we're going to work in the radians. So settings, we go to settings, radians, degrees. We want in degrees, so we change that to degrees. What was the domain of the graph? Negative 210. So I'm going to go to 225 and 150. Okay, so just look at the graph quickly. So we are drawing the graph. So the sine 2x. So what we have to do first is we're going to say y is equal to sine. We take out 2 as a common factor. So it's going to be x plus 30. Okay. So the period is going to divide itself by 2. Not so. The period gets divided by 2. So the steps, which is normally 90, is now 45 degrees, not so. And this graph is moving to the left by how much degrees? 30 degrees. So 45 minus 30 is going to give you an answer 15. So I'm going to use steps of 15. Are you all okay with that? And I've explained that as well, I think in the previous video. So there's going to be 165 steps of 15. auto show grid 15. Okay, so since this graph has an amplitude of 1, so I'm going to make it a bit bigger, so it's 1.25. So it's negative 1.5. Right, so let's take this out. Copy. Okay. So, what do we know, people? If we draw the basic sine graph, okay, then the basic sine graph will look like it. Not so. This point here is normally 360. That's a sine x graph. Not so. So, if I put a 2 in front of that, this point now becomes 180. So, that is now 90 and 45 and so on. Then the graph moves 30 degrees to the left. Okay, so that is 90 and 1. So that is 0. So if I move this graph 30 degrees to the left, it will go there. Not so? This is 90. This is 45 now. 30 degrees to the left takes you to 15. Not so? Then 90 degrees, 30 degrees to the left will give you 60. Not so? That is 135. 30 degrees to the left is 105. Which is there. And 150. 180 is now 150. Did you see that, people? So basically it just repeat itself on this side. So negative 45, 30 degrees to the left will give you negative 75. Negative 90, 30 degrees to the left is negative 120. Okay? So that is negative 135, 30 degrees to the left, 165. I think it's this one here. And then 210. So what I do is I just connect the dots. Do what I do best, no? Note it's going through that point there. This point there is your y-intercept, which I can calculate. So for the y-intercept we can say it's sine 2 open brackets, what is that, 0 plus 30. So that's 60, so it's root 3 over 2, which is 0,866 or root 3 over 2. I'll just put that there, root 3 over 2. Okay, since these are turning points here, so I write that in. So it's going to be 15 degrees. 15 degrees and 1. This is 105 and minus 1. So this is negative 75 and minus 1. This is 165. Okay. There's that graph. But we also see that this can actually be done with a calculator as well. So what we do is, with a calculator, we put it in table mode, so I press 7, some of you are going to press 3. I punch in the formula, so it's going to be sine 2 open brackets. Normally I get it in that form. Okay, first, of y is equal to a sine b into x plus b close brackets plus b. So that you're going to have x, so you press alpha, that plus 30 equals, there's no g of x, we're going to put two graphs in one there. We said we're going to start at negative 210 and we're going to end at 150 and you're going to be steps of 15. Okay, you now know how to determine that. People at this point were told insufficient memory. Okay, so what do? We minimize it a bit. Okay. So we're going to go from, you press AC, you press equal to, we're going to start negative 120 till 0. Steps of 15, and there we go. Again, we only take the rational values. So negative 20 is, negative 210 is 0. I could have taken negative 135 and marked it nicely a half on here. As you can see, it's very close there, but not exactly that way. If you're that kind of girl who likes everything perfect, you could have gone for the halves as well. Okay. So then negative 180, you don't need that, it's irrational. Negative 165, as I've indicated there on the graph, and so on and so on and so on. Then what we do is we press AC equals start now at 0 and end at 150. And we go again. We just take those readings again. Okay. Any confusion there? No? So it says sketch, so we've got another graph here. Alright, so the normal cos graph is always steps of 90, but it's a 45 degree shift. So when we say 90 minus 45, it gives you 45. So we're going to make steps of 45 degrees there now. Okay. So again, I'm going to negative 225 to 225. So it's negative 240 to 225. So it's 240. Well, you said steps of 45. What's the 225? What's 225 plus 45? 270. Just check there. 270. Let's just make it 270 instead. Otherwise, it's going to give me odd values there. Well, why do I go a bit over is because if I stop at 225, the start and stop, if I draw my axis and I cut off at 225, then you're not going to see this value of 225 on the graph. Then the program cuts it off at that point. Because as you can see here, it just the amplitude of 2, so I'm going to make it 2.2. Okay, and I'll show you now what I'm talking about. Okay, so what I try to indicate here is that if I, okay, the graph is just a bit too big. There we go. If I had to start and end at negative 225 when I sketch the graph, then it will cut this off. As you can see, I've actually started at negative 270, and you don't even see 270 on this axis. Can you see that? And that's why I just went a bit over so that it can make more sense to you when I draw this graph. Okay, so let's look at this quickly. The amplitude of this graph, of course, the cos graph is now 2. Okay, and the graph now shifts 45 degrees to the left. No, to the right. So that is normally 360. That is normally 180. This is normally 90. So I must move all that point 45 degrees to the right. So 0 and 2 becomes now 45 and 2. Not so. That is this point here. Let's go to the next one. 90 and 0 becomes 135 and 0 now. 180 and negative 2 becomes 225 and negative 2. So 225 and negative 2. I'll move the calculator away. shortly. So we go on the side as well. So negative 90 becomes negative 45. That is negative 180 becomes negative 135 and negative 2. This is 45 and 2. Okay. This is normally negative 270. No? 270 plus 45 is 225. Negative 225. You all agree with that? So what do I do? Connect the dots. Freehand. Okay, and there is that graph. Important thing here, we're going to need that point, which is your y-intercept. How do you calculate the y-intercept? Let x equals 0. So you just get it in normal mode, you press mode and 1. So you say 2 cos 0 minus 45. Give me an answer for root 2, which is 1,442 something. Okay. We send it to decimal, 1,414. Okay. Does it make sense, people? Otherwise, you can use it using drawing using the graph as well. We press mode, table. Okay. So mode table. Now we enter the diagram and the formula. So the equation of the graph. F of x is equal to 2 cos x, which is alpha x minus 45 degrees. So make sure your calculator has a D on top, okay? As the calculator needs to be in degrees. Okay. So we'll just check if the sound is on this thing. Hello? Yeah. Okay. You know, work on the board. The many things are better and then some things are worse. No? But he's much better, I think. Alright, so yeah, we'll be back at this here. So we're going to go, so if it's equal, g of x, you could put two graphs on the axis, one on the calculator once. We'll give you two sets of reading there. We're going to start at negative 225 and we're going to end off at 225. Then you're going to have steps of 45 degrees. So negative 225 is 0, as you can see it's on the graph here. And then we got negative 180, I'm not interested in. Negative 135, then we have and so on and so on. We just take the readings from. Okay, is there any confusion there? No? So this, I think there's another graph, a tan graph. Yep. Which page are we on now? 208. This example is on page 208. Huh? Okay. Now we also sketch the graph of the tan graph. For y is equal to, so what's the first thing we need to do? We take out 2 as the common factor. We always wanted x on its own and you can see the shift of the graph. Okay. People, the steps of the tan graph is normally 45 degrees. Not so. But now we have a 2 in front of the x. So 45 divided by 2 is 22,5. Then 22,5 is shifting 45 degrees. So 22,5 minus 45, negative 22.5. Which means to say, the steps is going to be 22.5. Okay. Let me just prepare that axis quickly. So it's negative so we're drawing it from negative, what is the line of the graph? Negative 135. So you say negative 135 plus 225, minus 225, 22.5. Negative 157.5. No man. Yes, you're right. Did you say 90 plus 22.5? 11.5. Okay, this is again just to what's the name? The axis there. So we're going to be in 22.5 steps. Okay, so the y-axis, because of the tan graph, it goes to negative infinity and positive infinity. I'm going to rather make it to 4 in both cases, 4 and minus 4. Steps of 1. Okay, so let's copy that. Okay. So again, people, when we draw the tan graph, that's what the tan graph looks like at 90 and negative 9. Not so. And then that goes from 0, that is normally 45, and 1. Okay. So, if the graph is 2x, then this is now at 45 and at negative 45. Not so. Then the graph moves 45 degrees to the left as its additive inverse. So if I move this asymptote 45 degrees to the left, where does it go? 0. Not so. So it's on this. Now there's nothing wrong with us where we're going to draw a dotted line and a solid line. Okay? But we know that this is an asymptote. Not so. Now if you move this point 45 degrees to the left, it goes to negative 90, which is this point here. Did you see that? X is equal to 90. So midway between these two is 45. This, which is 45 and 1, becomes 45 degrees to the left, is negative 225. This now not 45. This normally 45 is now 225. Sorry, 45 degrees to the left will give you negative 225. Okay, you all agree with that? So that is negative 2.5 and 1. Now this point here, which is normally 45, must be divided by 2. So it's negative 225. Moving 45 degrees to the right is negative 67.5. You all agree with that? So I know the graph is coming close but does not touch. And there is the first graph. Okay. From there I just take the cube or the what's the name from here? So that's going to be 90 to 90 degrees. So here's your next asymptote. So x is equal to 90. Midway will be 45, 225 and negative 1, 67.5 would be there, and there I go again. There's that graph. Okay, and the last one is cutting at negative, so it starts there, it has to go through there, and then this I don't need anymore. Okay, that is how life is. If people don't need you anymore, they cut you out. Yeah? Learn that very soon in your lives, people. Okay? You'll save yourself a lot of heartache. No? And there you go. Alright, you guys understand? Right. So of course we could have done it to the calculator. Again, you need to first get it in this form here. Okay? So in our calculator we say then table is going to be tan 2 open brackets, or you can type it in the original format if you like, but the reason why we do it so that we can work out our steps. Okay, so So it's 2 into x, which is your alpha here, plus 45 equals, we're going to start at, okay, now we're into fast, so again this is AC, we're going to start at negative 135 and we're going to end off at 90. Steps of negative to 2.5. Math error, so let's check where they go wrong. So that shouldn't make any difference. We're going to start at negative 3 to, yeah, that's correct. Let's end up at 0. Steps of 2 to, oh yeah, steps is normally positive. What's wrong with me? Many things, no? Many things. So it's going to be 90. It's almost sure that the calculator could have handled that. So negative 135, as you can see, is at 0. Can you see that, people? And then negative 120, 112.5 is at 1. Error means asymptote, and so on, and so on, and so on, and so on. Alright, you guys understand? Easy done, no? So with that, you should have been able to do. I thought you got something mathematical to us. Now go quickly. People, you guys understand? Alright, so that basically means the end of this. And with that, you were able to do exercise 6.7. Okay. So I've explained to you in our last lesson how the trigonometric equation works. Not so. Alright. So we'll do that video now as well. Let's stop this video.